Let's dive straight into a really familiar and frankly painful reality: debugging a production error. You've got your stack trace over in Sentry, the commit history in GitHub, and the affected rows sitting in a staging database somewhere. Right now, you're probably jumping between tabs, basically acting as a human clipboard for an AI that's just sitting there, waiting for context it could have easily fetched itself. Well, in this explainer, we're going to look at the immediate cure to this inefficiency: MCP server configuration in Claude Code. Contrast that old manual workflow with the new way. The old trap literally forces you to be the manual bridge between your tools and your AI. But MCP server configuration, it completely automates this. You aren't just handing Claude the information anymore. You are actually giving it the keys to go get the data itself. And that brings us to the absolutely crucial stat for this new workflow: 0. That is the exact number of tab switches you're going to need. With just a single prompt, Claude can now correlate a CPU spike, a Git log entry, and a complex datamese query result all in one unified session. No tab switching required. So what is MCP exactly? It stands for Model Context Protocol. Basically, it's an open standard that allows Claude Code to connect to external systems through a really consistent interface. By configuring an MCP server, all those external capabilities suddenly become callable tools for Claude. It allows the AI to read files, run queries, or manipulate issue trackers directly on its own. Now, these servers run in two primary ways. You've got local, standard I/O servers for processes right on your machine, and then remote HTTP servers for vendor-hosted network endpoints. And as for your configurations, those live in either a project-scoped .mkc.json file, which is great because you can share it via your repo with your team, or a personal .claude.json file for your own machine-specific tools. What's really interesting is how a single config file can define multiple completely distinct servers, like your file system, your metrics, and your observability tools. When Claude starts up, it reads this config, and if you just type the /MCP command into the terminal, you get this live readout of your active connections. This lets Claude seamlessly correlate tool calls from all those configured servers at once. Section 1. The one example, fixing issue number 42. Let's see how this actually plays out in a real-world production incident. First up, you have to note the credential safety pattern here. When you're authenticating with something like GitHub, you never want to write your personal access token directly into a committed file. But using shell environment variable syntax, like a GitHub token variable, the config safely references the token. That means you can commit the file and share the whole shebang with your team completely securely. So when a developer simply prompts fix issue 42 and open a pull request, Claude just takes over and executes the sequence automatically. It fetches the issue criteria, writes the actual fix, creates the branch, commits the change, and opens the PR entirely on its own. Literally no browser, zero context switching. As a general rule of thumb, you want to use MCP whenever Claude needs live data or needs to take actions mid-session. Use local standard I/O for your machine's CLI tools or local databases, and use HTTP for remote vendor endpoints. But quick heads up on a practical limitation. Claude reaches remote HTTP servers from Anthropic's infrastructure. So if your remote server is sitting behind a corporate VPN, it's not going to work unless you explicitly allow list it. And this brings us to our key takeaway. This represents an absolute paradigm shift. MCP server configuration evolves Claude Code from a passive assistant that just waits around for you to paste in context into an active agent that goes out and retrieves its own context. It is a massive leap forward in developer efficiency. So, are you ready to master these configurations for your own team and avoid the common setup pitfalls? You can check out 3 fully worked examples over at cloudmaster.net. But before you do, I'll leave you with this thought. If an AI can retrieve its own context and ship a pull request entirely on its own today, what parts of your daily workflow is it going to completely replace tomorrow?